For the last decade, cloud engineers have basically been taught a golden rule.
Right. Stateless is scalable.
Exactly. Stateless is scalable and stateful is a bottleneck. You
Okay.
build your application layer to process a request, drop the memory, and just move on.
Yeah, and if you need persistence, you push it down to a database.
Right. But if you look at the AWS release notes for mid-March 2026, AWS is suddenly rewriting that rulebook entirely.
They really are.
They're injecting persistent state right into the ephemeral compute layer while simultaneously exposing bare metal silicon controls that we, usually assume are abstracted away.
It's a massive architectural collision. I mean, we are seeing high-level managed services suddenly expose deep architectural controls.
Yeah.
And at the same time, foundational compute layers are adopting the automated stateful behaviors we normally associate with the application layer.
So welcome to the deep dive. Our mission today is extracting the most critical engineering signals from the noise of the past week's AWS announcements, specifically from March 9th to March 13th.
There's a lot of noise.
There is. We have 45 distinct updates to cover. So to make this actionable for you, we've grouped these releases into 6 technical themes based on the stack.
Right.
We're starting at AI development, moving through observability, data architecture, bare metal compute, security hardening, and finally, enterprise workflows.
And if we look at the overarching technical direction of this specific week, it's defined by the aggressive automation of complex configurations, really.
And hardening the infrastructure.
Exactly. Hardening it against next-generation threats. We are moving past the initial experimental deployment phases of generative AI and focusing entirely on integrating it securely into production-grade architectures.
Let's start right at the application layer with the evolution of AI development and agentic workflows, because we are looking at a fundamental transition in how generative AI is implemented.
Yeah, it's moving from raw, stateless model API calls into persistent, integrated agentic workflows.
A prime example of this is Update 32. Amazon Bedrock Agent Core Runtime now supports Stateful Model Context Protocol, or MCP server features.
This is a significant architectural shift. Previously, managing session context across multiple interactions required you to build and maintain external state stores.
Right, you'd have to spin up Elasticache.
Exactly. You had to provision an Amazon Elasticache or a DynamoDB table just to remember what the user said 3 prompts ago.
Which is a headache.
It is. But now, with stateful MCP sessions, each user session runs in a dedicated micro VM. This micro VM isolates resources, and the server maintains the session context natively across multiple interactions using a dedicated mixed session AID header.
Okay, wait, I have to push back on the architecture here.
Sure.
Does introducing state via dedicated micro-VMs contradict the inherently stateless, ephemeral design patterns engineers usually strive for in serverless architectures? I mean, we usually want to avoid pinning sessions to specific compute instances because it traditionally breaks horizontal scalability.
That is a highly valid architectural concern, actually. Pinning state traditionally does break horizontal scalability because traffic routing becomes incredibly complex. However, the micro VM implementation here abstracts the compute provisioning completely away from the developer. You are not managing the lifecycle or the load balancing of that micro VM.
Oh, so the service handles it.
Exactly. The Bedrock Agent Core runtime handles the underlying routing table. It allows your application code to remain entirely stateless while delegating the complex, memory-intensive conversational state management to the underlying managed runtime.
That makes sense. And that persistence is critical for real-time progress notifications during long-running operations, which, speaking of memory management, Update 14 complements this by shifting agent core memory to streaming notifications via Amazon Kinesis.
Oh, the streaming updates, yeah.
Right, because previously, if you wanted to know if a long-term memory record was modified by an agent, you had to implement continuous polling logic.
Which is terribly inefficient.
Completely. Now, those updates stream directly to Kinesis whenever a memory record is created or modified. You'd eliminate the compute overhead of polling entirely.
By eliminating that polling logic, you are cutting out hundreds of lines of boilerplate code and reducing unnecessary API calls.
And to further help monitor these complex streaming workflows, Update 33 introduces 2 new CloudWatch metrics, which are time to first token and estimated TPM quota usage.
Time to first token is crucial for streaming APIs. It measures the exact latency from request transmission to the first received token at the network edge.
Which is much more accurate than what we used to do.
Yeah. Vastly more accurate.
Before, we had to rely on client-side instrumentation to measure time to first token, which meant you were capturing the user's local network latency rather than the actual model performance.
Right, and tracking it server-side allows you to establish stringent SLA baselines.
Exactly. And the other metric, estimated TPM quota usage, tracks your tokens per minute consumption, factoring in cache write tokens and output burn down multipliers, so you can set proactive CloudWatch alarms before you hit those hard API rate limits.
We are also seeing these AI patterns integrated directly into developer tooling. Update 2 introduces the AWS Serverless Application Model, or SAM, Kiro Power.
Yeah.
This allows developers to use AI agent-assisted development directly in their local IDE for initializing SAM projects and testing Lambda functions locally.
And moving from local development to cloud deployments, Update 10 open sources the Landing Zone Accelerator MCP Server.
And the LZA is notoriously complex to configure.
It really is. So this update provides 20 specialized tools for managing LZA deployments through natural language. It runs as a containerized MCP endpoint with temporary credentials.
So you can essentially ask your IDE why specific control tower deployment failed, and it parses the documentation for you.
Exactly. Furthermore, Update 41 for Amazon Quick Suite introduces user preferences, allowing the persistence of chat settings, agent selection, and personal context across sessions.
But, building and deploying those advanced AI applications requires significantly more robust infrastructure as code and observability tooling.
Yeah, the deployment layer has to keep up.
Exactly. If the application layer is getting smarter, the deployment layer needs to be more resilient. That brings us to our second theme, refactoring the developer and operations experience.
Let's talk about Update 13, the general availability of AWS CDK Mixins. This solves a massive headache for platform engineering teams.
It really does.
Traditionally, developers had to choose between using L1 constructs, which give you immediate access to new AWS features, or building complex L2 constructs to enforce organizational security baselines across the company.
Right, the classic trade-off.
But Mixins bridge that gap. They allow you to apply reusable abstractions such as auto-delete, bucket encryption, or block public access directly to any L1 or L2 construct using a straightforward dot with syntax.
So you do not have to rewrite your existing infrastructure code to enforce a new security policy.
Exactly.
The mechanism there is a late-stage synthesis modification. When the CloudFormation template compiles, the Mixin intercepts the specific node in the construct tree and injects the required properties.
That's super powerful.
Moving up the stack to observability, Update 1 introduces new service-level objective capabilities in CloudWatch application signals.
Okay.
It analyzes 30 days of service metrics, specifically P99 latency and error rates, to suggest data-driven reliability targets. This eliminates the guesswork often associated with setting SLO thresholds, which frequently leads to arbitrary pager alerts and alert fatigue.
Wait, I have a question about the logic engine driving those recommendations.
Sure.
If an application has been poorly optimized, missing indexes, or running in a degraded state for the last 30 days, doesn't an automated analysis risk codifying that degraded pipeline as the new acceptable target? You're essentially telling the system that a 5-second database query is normal.
It absolutely carries that risk if the engineering team applies the recommendation blindly.
Right.
The automated suggestions are designed to be validated before implementation. The core value is establishing the mathematical reality of your current architecture's performance rather than an aspirational goal.
Oh, I see.
If the system recommends a P99 latency of 5 seconds, and that is unacceptable to the business, it immediately flags a necessary architectural refactor. It shifts the conversation from, why is the alarm broken, to, why is our baseline performance so poor?
That's a great point. And visibility is also improving on the actual deployment execution side. Update 11 adds a Deployments tab to the Elastic Beanstalk environment dashboard.
Long overdue.
Seriously. It provides real-time, step-by-step logs for in-progress deployments. Anyone who has used Beanstalk knows the pain of waiting 15 minutes for a deployment to fail, only to then fetch the logs to see that a single dependency failed to install on line 3.
Now you see that failure instantly.
Yeah.
To handle the larger analytical workloads required by these observability features, operational limits are expanding. Update 40 increases CloudWatch logs, Insight's query language concurrency to 100 concurrent queries per account, and increases API limits to 10 calls per second per region.
That's a big jump.
Yeah. Update 25 expands CloudWatch database insights on-demand analysis to the AWS GovCloud regions, utilizing machine learning models to identify database performance bottlenecks in highly regulated environments.
Nice.
And Update 34 expands platform access by adding GitHub and Amazon social logins to the AWS Builder ID.
So all of the sophisticated application code and observability tooling is basically useless without frictionless data pipelines beneath it.
Entirely useless, yeah.
Let's move down the stack to the data persistence layer for our third theme, data plumbing. A massive foundational architectural shift was announced in Update 18. Amazon S3 account regional namespaces for general-purpose buckets.
This fundamentally alters how storage architecture is designed and governed on AWS.
It's huge.
Since S3 launched, bucket names required global uniqueness across all of AWS. If someone in another company took your desired bucket name, you couldn't use it. But with account regional namespaces, you create buckets within your own reserved namespace tied to your AWS account ID.
This guarantees predictable bucket naming across multiple regions. You no longer have to append random hashes to your infrastructure as code deployments just to ensure the bucket creation doesn't fail.
Right.
More importantly, security teams can now use service control policies to enforce that all new buckets are created strictly within the account regional namespace.
This standardizes multi-tenant architectures and data governance, ensuring no data is accidentally written to a legacy, globally named bucket.
For search and analytics storage, Update 38 allows Amazon OpenSearch service in-place volume increases beyond 3 TB without requiring a blue-green deployment.
That's a huge operational win.
Yeah. Previously, expanding beyond that threshold required provisioning entirely new underlying instances and migrating the data, causing performance degradation during the sync.
Update 9 also introduces OpenSearch cross-account data access from within a single OpenSearch UI application. It natively supports IAM and IAM Identity Center authentication to query indices across organizational boundaries.
On the data ingestion side, Update 16 enhances AWS Glue Zero ETL integrations with Amazon DynamoDB. It introduces configurable change data capture, or CDC, refresh intervals ranging from 15 minutes to 6 days.
And it also allows on-demand data ingestion.
Right. This provides direct engineering control over the trade-off between data freshness and pipeline operational costs. If a downstream dashboard only needs daily updates, you are no longer forced to pay for continuous CDC streaming.
Now contrast that server-side ingestion with what is happening on the client side in Update 44.
Yeah.
Amazon SageMaker Unified Studio Visual ETL introduced Data Preview version 2.0.
Okay.
It utilizes an in-browser query engine based on WebAssembly to process data locally, delivering transformation results in about 1 second without initiating a server-side Spark session.
Okay, I need to probe the physical limitations of that in-browser query engine.
Just go ahead.
If a data engineer is working with a 50-gigabyte Parquet file, doesn't moving data processing to the local browser risk severe memory constraints and browser crashes? You cannot load that much data into local RAM.
You cannot, which is exactly why the execution mechanism here is highly specific.
Oh, how so?
The data preview fetches a constrained 10-megabyte sample size from the source rather than the entire dataset. The browser caches that sample locally. The purpose of Visual ETL Data Preview is validating the transformation logic, ensuring the schema maps correctly and the regex functions behave as expected on messy data. Once the logic is verified on the sample data in the browser, the actual job is compiled and executed against the full 50-gigabyte dataset on the server-side Spark infrastructure.
It's about accelerating the iteration cycle, not shifting the heavy compute to the laptop.
Exactly. Rounding out the data layer updates, Update 31 adds native spatial data support to Amazon Neptune database, includes 11 built-in spatial functions following the ISO 132493 standard, natively supporting geometry data types compatible with the OpenCipher query language.
And we also have rapid regional expansions for data services, right? Update 20 brings Neptune to the Hyderabad region, and Update 5 brings Amazon MSK standard brokers running on Graviton3 M7G instances to Cape Town.
Now, pushing massive volumes of data requires raw silicon. That transitions us to our fourth theme, the compute layer.
Yeah.
To support complex workflows, the underlying compute architecture is being pushed to its physical limits. But we are also seeing compute paradigms blend, as shown in Update 8, where AWS Lambda managed instances now support Rust.
Let's break down the mechanics of that. Lambda managed instances are fully managed EC2 instances with built-in routing, load balancing, and auto-scaling.
Right.
They combine the serverless operational model of Lambda with the pricing advantages of EC2, like compute savings plans. Adding Rust support enables parallel request processing within each execution environment on those instances.
And that parallel processing capability is the key mechanism.
Yeah.
Rust's memory safety and low runtime overhead are uniquely suited for concurrent execution.
Oh, absolutely.
It allows developers to extract maximum throughput from the underlying EC2 compute without having to manage the operating system, patch the kernel, or configure the network routing.
Structurally, though, by exposing the underlying EC2 pricing mechanisms and enabling parallel processing traits within the execution environment, are we blurring the line so much that it defeats the original pure event-driven purpose of Lambda? I mean, the entire premise of serverless was one event, one execution environment.
It definitely redefines what Lambda means for sustained, high-throughput workloads. Pure, event-driven, single concurrency execution still exists and remains optimal for highly variable, spiky traffic.
Right.
However, for predictable, high-volume applications,
Yeah.
adhering strictly to the single concurrency model results in underutilized silicon. You end up paying for CPU cycles you aren't using.
That makes sense.
Lambda-managed instances with Rust provide a pragmatic middle ground, retaining the automated control plane of serverless while exposing the sustained computational economics of standard EC2.
Speaking of raw computational power, we are seeing a massive global hardware refresh cycle aimed at solving specific physical bottlenecks.
Massive is the right word.
Yeah, Update 4 brings M8 instances to the Ohio region. These instances feature 5th-generation AMD EPYC processors hitting a maximum CPU frequency of 5 gigahertz in the cloud, accompanied by a 10x larger L3 cache compared to previous generations.
A 5 gigahertz frequency combined with a massive L3 cache is designed explicitly for workloads where single-thread execution speed is the absolute physical bottleneck.
So high-frequency trading.
Exactly. This is hardware purpose-built for high-frequency trading and real-time financial analytics, where nanoseconds of instruction retrieval time dictate financial outcomes.
Wow.
Conversely, Update 45 addresses massive parallel processing needs by launching G70 instances in Seoul and Spain. These instances feature up to 8 NVIDIA RTX PRO 6000 Blackwell Server Edition GPUs with 96 gigabytes of memory per GPU.
That's specifically targeting the memory constraints of large language model training, right?
Exactly.
For enterprise in-memory databases like SAP HANA, the bottleneck is often DDR5 memory bandwidth. Update 27 addresses this by introducing U7i high memory instances powered by custom 4th-generation Intel Xeon scalable processors, offering up to 8 terabytes and 12 terabytes of DDR5 memory.
And we are seeing this hardware roll out globally to address that exact memory bandwidth constraint across all architectures.
Yeah, just rattling them off. Update 3 brings AMD Turin-powered R8A instances to Tokyo. Update 7 expand HPC 8A instances to Tokyo and GovCloud. Update 15 launches custom Intel Xeon 6 M8i and M8i Flex instances in Ireland and London.
Update 22 brings C8 instances to Spain. Update 23 launches Graviton 4 Z8AG and M8GD instances in Sao Paulo and Ireland. And Update 24 brings Graviton 3 R7GD instances to Sao Paulo.
That volume of fleet expansion across Intel, AMD, and custom Graviton silicon indicates a comprehensive architectural upgrade.
AWS is physically replacing the foundational hardware globally to ensure all Tier 1 regions have access to the increased throughput of local NVMe storage and DDR5 memory channels.
But deploying 5 gigahertz instances globally means we are processing more sensitive data closer to the edge than ever before.
Which brings new risks.
Exactly. Moving that compute power outward drastically expands the cryptographic attack surface. And that brings us to our 5th theme, hardening the cloud. We are seeing a significant elevation in the baseline for cryptography and network security. Update 43 is highly technical and critical.
Yeah, IAM Roles Anywhere now supports the MLDSA post-quantum digital signature algorithm.
Right.
IAM Roles Anywhere allows workloads running outside of AWS, like on-premises servers, to obtain temporary AWS credentials using X.509 certificates. Historically, those certificates have relied on lattice-based cryptography to verify the signature.
Okay.
The MLDSA algorithm, standardized by NIST, relies on lattice-based cryptography, making it mathematically resistant to decryption by quantum computers. By allowing MLDSA signed certificate authority certificates to act as trust anchors, AWS is protecting certificate-based authentication from future large-scale quantum threats.
I have to question the immediate operational urgency here, though.
Okay, why is that?
Our harvest now, decrypt later attacks a realistic concern for ephemeral authentication sessions. A temporary AWS credential expires in an hour. Even if a quantum computer decrypts the session payload 10 years from now, the credential will be useless. Is implementing MLDSA purely preventative architecture for the next decade?
You are correct that harvest now, decrypt later is primarily a threat to data confidentiality,
Hmm.
not immediately to ephemeral authentication payloads.
Right.
However, the root certificates in a public key infrastructure are often valid for 10 to 20 years. If a quantum computer becomes viable within the lifespan of your current root CA, a threat actor could forge client certificates.
Oh, I see.
They would need to decrypt old sessions. They could generate valid new credentials and gain unauthorized access to your AWS environment today. The urgency is that PKI rollover takes years to propagate across enterprise hardware, so the root of trust must be updated today to secure the architecture of tomorrow.
That structural context is vital. Also in the security theme, moving from cryptography to network resilience, Update 39 announces the general availability of Amazon Route 53 Global Resolver.
This provides an internet-reachable, anycast DNS resolver across 30 AWS regions.
But the critical engineering mechanism here is the built-in DNS query filtering, which adds protection against dictionary domain generation algorithms, or DGA.
And DGA is commonly used by malware to dynamically generate thousands of domain names for command and control communication, evading static block systems.
Right.
Dictionary DGA uses combinations of standard words to make the generated domains look legitimate to basic security filters. Global Resolver analyzes the entropy and linguistic patterns of these queries directly at the DNS resolution layer. It drops the resolution request before connection is even attempted, neutralizing the malware's ability to phone home.
On the data resilience front, Update 19 adds logically air-gapped vault support for Amazon EKS within AWS Backup. It stores immutable, encrypted backups that can be shared across accounts using AWS Resource Access Manager.
That is critical for ransomware recovery, where the primary account is entirely compromised.
Definitely. Update 30 expands AWS Backup for Amazon RDS multi-AZ clusters to 17 additional regions. And for internal networking, Update 12 allows the AWS Private CA connector for SCEP to support AWS Private Link, keeping automated mobile device certificate enrollment traffic entirely within your VPC perimeter rather than traversing the public internet.
Which is much safer.
Yeah. Finally, for regulatory compliance boundaries, Update 6 launches AWS Network Firewall in the European Sovereign Cloud. Update 21 brings AWS Firewall Manager to New Zealand, and Update 42 expands Cognito to Taipei and New Zealand.
These updates collectively ensure that as workloads scale across those new high-performance compute instances, the boundaries containing them, whether cryptographic algorithms, DNS resolution paths, or VPC perimeters, are hardened against automated attacks.
Let's bring this all together in our final theme. Enterprise workflows. We are seeing how these back-end improvements in AI, data analytics, compute, and security finally surface in end-user business applications.
Yeah, Amazon Connect is aggressively integrating AI directly into the contact center data pipelines. Update 37 introduces an AI-powered manager assistance preview, allowing natural language queries across 150 different Connect metrics.
Instead of a business analyst manually building SQL queries or static reports, managers can query the system natively to identify which queues are at risk of missing service-level targets.
They receive algorithmic recommendations for recovery actions, such as shifting specific agents between channels.
This is backed by the compute scale of Update 35, where AI-powered predictive insights have scaled to support up to 40 million product catalog items for trigger-based customer outreach campaigns.
For communication ingestion, Update 36 introduces conversational analytics for email. It automatically categorizes inbound emails, generates contact summaries, and redacts personally identifiable information, or PII.
You can configure the system to replace specific PII types with indicators like bracket SSN or generic markings.
The crucial mechanism here is that it stores the redacted and original versions in separate secure storage locations before the email is even routed to an agent's queue.
But what are the latency and privacy implications of running real-time conversational analytics and automated PII redaction directly in the email ingestion pipeline of a high-volume contact center? You're adding heavy NLP processing to the very front door of the system.
Executing NLP models on incoming text does introduce milliseconds of computational latency. However, email is an asynchronous channel, so a 200 millisecond delay during ingestion is entirely imperceptible to the customer.
Right. What about privacy?
Regarding privacy, performing redaction at the absolute ingestion boundary is highly optimal. It reduces the internal blast radius of sensitive data. Because the PII is scrubbed before it persists in downstream operational databases or appears on an agent screen, you drastically minimize your compliance risks and auditing scope.
That makes a lot of sense. To complete the Amazon Connect updates, Update 26 adds integrated workflows for managers to create and track coaching plans based on interaction evaluations directly within the UI.
Update 28 allows administrators to configure multiple from email addresses per queue, simplifying outbound routing.
And Update 29 makes Amazon Connect cases data natively available in the analytics data lake, queryable via Athena or QuickSight without requiring custom export scripts.
Finally, looking at end-user compute security, Update 17 announces Amazon Workspace's support for Microsoft Windows Server 2025. This specifically enforces enterprise security standards like TPM 2.0 and UEFI Secure Boot, bringing zero-trust hardware validation to virtual cloud desktops.
So synthesizing all 45 updates this week, the engineering trajectory seems really clear.
It is. AWS is heavily focused on removing operational friction, implementing zero ETL configurations, automated SLO analysis, and AI-assisted configuration management.
Yeah.
But they are doing this while quietly swapping out the foundation beneath us with vastly more powerful and secure technology. From Blackwell GPUs and 5 GHz processors to post-quantum cryptography.
It really forces us to examine where the engineering boundary is moving. As tools like the LZA MCP Server and CDK Mixins automate away the drudgery of configuration and compliance, are we approaching a state of self-organizing cloud infrastructure?
That's the question.
If the cloud begins to manage its own scaling, its own security baselines, and its own data pipelines, does the role of the cloud engineer shift entirely away from operations and purely into system design and business logic?
It's definitely something to think about.
Thank you for joining the deep dive.